Well, hello, I'm Dean Kereiakes. I'm chairman of the Christ Hospital Heart and Vascular Institute, professor of medicine, University of Cincinnati, and clinical professor of medicine at The Ohio State University. I'm also deputy editor of SCAI. We're here to discuss an important paper that'll be appearing in SCAI entitled Long-Term Outcome of PCI Using the Absorbed Bioresorbable Vascular Scaffold, a SCAAR study. It's a Swedish coronary angiography and angioplasty registry. We know that over the past 30, 40 years, the metallic stents have undergone an evolution from bare metal to first and then new generation DES. And through that evolution, we've seen a progressive stepwise reduction in device-oriented composite endpoint of target lesion failure to 1 year, with the lowest incidence events being with new generation DES. But beyond 1 year, there appears to be at least a 2 to 3% per year annualized rate of target lesion failure, regardless of device. Now, this has been ascribed to the persistent metallic frame that cages or distorts the vessel, limits phase of motion compliance, and positive remodeling. But I think this concept of leave nothing behind has been intriguing, if not captivating, for everyone here in today's discussion. There are very few data beyond 3 and particularly 5 years available for the BVS, absorbed BVS device. Well, here to present the SCAAR study that will give us unique insights is Dr. Saman Saidi, and our panel is none other than pioneers in coronary stenting and particularly bioresorbable vascular scaffolds, and that is Gregg Stone, professor of medicine, the Icahn School of Medicine, Mount Sinai, and Serruys, professor of medicine and innovation at the University of Galway in Ireland. Dr. Saidi, please describe your study and the results.
Thank you very much for the invitation. I am privileged to have been given this opportunity to present our paper on behalf of all authors. Allow me to start with a bit of background. As described before, despite efforts to refine implantation techniques with meticulous pre-dilatation, high-pressure post-dilatation, and the use of intravascular imaging, bioresorbable scaffolds have been associated with inferior outcomes compared to contemporary permanent metallic drug-eluting stents, particularly within the initial years after implantation. However, the long-term performance remains uncertain. We analyzed continuous non-selected data from the Swedish Coronary Angiography and Angioplasty Registry, SCAAR, which holds mandatory data from all consecutive coronary angiographies and PCI procedures from all 28 Swedish cath lab sites. This high quality and reliable data from SCAAR receives bi-weekly updates on vital status and date of death from the National Population Registry. This gives us a robust endpoint for death, and since the vast majority of MIs are treated in CCU, the follow-up data for new events is close to 100%. So any revascularization performed in Sweden is registered in SCAAR, providing reliable follow-up data for that endpoint as well. The aim was to evaluate the long-term outcomes in all Swedish patients treated with bioresorbable scaffolds versus contemporary drug-eluting stents, assessing device-related complications and examining potential late benefits in order to clarify the balance between early risks and long-term advantages of bioresorbable scaffolds in clinical practice. A bit about the studied population. All patients in Sweden who underwent stent implantation with contemporary drug-eluting stents or bioresorbable scaffold between November 2011 and March 2018 were included in the study. Patients treated with old stents, including bare metal stents, non-contemporary drug-eluting stents, as well as uncommon stents or stents with low diameter were excluded. And so were patients with cardiogenic shock and very few with unknown vital status. A 2-to-1 propensity score matching was carried out with the nearest neighbor approach using a no replacement caliper method with a caliper 0.2. This produced a propensity score matched patient population of nearly 2,000 patients and a total of more than 2,400 stents. The median follow-up time was 7.3 years. Now to the big picture. Overall, bioresorbable scaffolds were associated with significantly higher early stent thrombosis, target lesion vascularization, and in-stent restenosis rates. The divergence occurred early and persisted throughout this study period. All-cause mortality, myocardial infarction, and any restenosis rates did not differ significantly over the entire study period. The landmark analysis, conditional on patients remaining event-free up to that point in time, was conducted to evaluate outcomes specifically beyond 3 years. So, beyond 3 years, the device-related outcomes converged. The confidence interval for stent thrombosis was wide, reflecting low event rates and limited power to detect meaningful differences, but overall, both devices appeared comparable in the late safety profile. There was no difference in rates of target lesion vascularization and in-stent restenosis between groups. The long-term all-cause mortality was nearly identical, and any restenosis rates did not differ between the two strategies, consistent with findings in previous studies. However, the significant reduction in rates of myocardial infarction with bioresorbable scaffolds from 3 years onward is a striking finding, suggesting a potential long-term benefit over drug-eluting stents once the scaffold is absorbed and the vessel may have returned to a more physiological state. So to sum it up, in this complete real-world, all-common nationwide population, all-cause mortality and MI rates with bioresorbable scaffolds were comparable to those observed with drug-eluting stents. Bioresorbable scaffold showed inferior early clinical performance compared with contemporary drug-eluting stents, but after 3 years, device-related outcomes were similar, while myocardial infarction rates favored bioresorbable scaffolds. These findings may imply that while early performance of bioresorbable scaffolds are inferior, a catch-up occurs later as the scaffold resorbs. This concludes my summary of our analysis, and thank you very much for listening.
Excellent presentation. I think this brought a number of questions, and I'm glad we've got a panel that includes Patrick, in addition to Gregg. And that is, even though you did propensity score matching, weren't there residual significant differences between the comparator groups in things like stent diameter, stent length, the frequency of post-dilatation, and the use of intravascular imaging, all of the above, which could have impacted your subsequent observations, particularly for stent thrombosis, target lesion revascularization? Is that true?
That is correct. I mean, although we've done everything we can to correct for these measures, there's still a possibility that they may play in.
Gregg, Patrick, there evidently is a difference that is statistically significant in the incidence of myocardial infarction beyond 3 years, that quote time point of complete scaffold resorption. But I don't think there's a p-value for interaction that's positive. Is that correct, Dr. Saidi?
That's correct.
Yeah. In the absence of a plausible explanation and no interaction, is this a matter of just power? Because the comparator groups are still relatively small, the confidence intervals are large, or is this something that you would say could still be play of chance? Gregg, you want to start?
Sure. Well, we had the honor to write the editorial for this manuscript, and I think it was absolutely fascinating. We had recently published in JACC Intervention the final report, if you will, from the Absorb clinical program, which were 5 randomized trials in approximately 6,000 patients, Absorb 2 in Europe, Absorb Japan, and Absorb China in Asia, and then Absorb 3 and 4 in the United States. And we basically found very similar increased 3-year adverse event rates in this pure randomized population compared to the Xience everolimus-eluting stent with the Absorb first-generation bioresorbable scaffold. But then from 3 to 5 years, the results were statistically indistinguishable between the two devices. And in fact, target lesion failure in a continuous spline analysis was actually slightly lower at the end of 5 years with Absorb compared to Xience. And very late stent thrombosis, even though it was infrequent, also tended to be a little bit less with Absorb compared to Xience. Now, a limitation of our analysis was we only had follow-up to 5 years. So what was, to me, most fascinating about this data was that there was follow-up to 10 years with a median of just over 7 years. So this, even though it was about a third the size, extended the follow-up duration. So I was most fascinated to see the significant reduction in myocardial infarction. But it did raise questions in my mind that we always have to be ask and be critical as to whether or not it's real. It was overall myocardial infarction. So we don't know if it was target vessel myocardial infarction versus non-target vessel myocardial infarction. That's point number one. And it is conceivable that there was longer duration of dual antiplatelet therapy used in the BVS group that might have reduced non-target vessel MIs. Second, if there is a reduction in myocardial infarction, why didn't we also see a reduction in target lesion revascularization and restenosis? Because presumably the way that Absorb would reduce myocardial infarctions in the target vessel would be to reduce MIs from either severe restenosis or stent thrombosis. So if there is a divorce here where there's no effect on stent thrombosis, no effect in TLR, can we believe there's a reduction in target vessel myocardial infarction? So while I was absolutely intrigued, and I must say the finding of a reduction in myocardial infarction meets my preconceived notions from what should occur from the technology, and I'll be very interested to see what Patrick says about that. I do think as a scientist, we have to ask some of those hard questions.
Yeah, Patrick, you want to address that? Very good points.
Yeah, I think it's a good point. I think that in general, we agree that there's a kind of passivation after 3 years. I mean, you know that when we saw this event around 3 years, obviously we were puzzled by that. But after 3 years, it seemed that there is a passivation. Now, there are 3 sets of data which is important. I mean, of course, the meta-analysis of Gregg and Ali, that's clear. These data that we see now, but we should not forget the data of Peter Smith. You know, Peter Smith did a big trial with 1,670 patients. Yeah. He has presented at PCR. The manuscript is circulating, so I'm sure it will emerge at some point. But I can repeat some of the point. What was interesting, it was science versus Absorb. There were some good things. I mean, PSP was mandatory. IVUS was about 25%. DAPT was for 13 months. 2 years, 47%, and 3 years, 34%. And then they had also a landmark analysis at 3 years because the whole follow-up was 7 years in all patients. So the follow-up was about 96% in both arms, the Xience and the Absorb. And in a nutshell, what you see is that in terms of death, after the 3 years, the landmark 3 to 7 years, no difference in death. If you look at definite stent thrombose, no difference between 3 years and 7 years. If you look at vessel myocardial infarction, I think the comment of Gregg is very judicious. Also, no difference. But what is a little bit surprising, they saw a still diverging curve in target lesion revascularization. But you should not forget the type of patient that they have included in that population. Let me see here. multivessel disease, where you could do it. Diabetic, you could do it. ACS, you could do it. Now, 12.9% of STEMI and 20% of non-STEMI. Long lesion could be done. Small vessel could be done. Bifurcation, total occlusion. So it was a kind of all comers. And I think that in that population, it is very interesting to see that on the key point of death, myocardial infarction, definite stent thrombose, there is absolutely no difference between 3 years and 7 years. Of course, we all agree that in the first 3 years, we see a different thing. I'm a little bit puzzled by the divergence in target lesion revascularization, but it's clearly seen. It's a p-value, let me see that, of 0.03, so it must be something quite robust in these 1,600 patients follow for 3 years. So I think that the common sense will say there is a kind of passivation, if I can say so, after 3 and 7 years. And then there are some divergence. I mean, the notion of less myocardial infarction after 3 years is very interesting, and the data of Gregg is also in the meta-analysis is also very important. Let me say one thing is that in my modest experience, all technology take a long years to emerge. I mean, my first biodegradable scaffold with ideotamide is the year 2000. So we are a quarter century later, and we still don't know what's going to happen. And, Absorb for me is 2006, 2008. So I think it's a little bit the philosophical notion. It takes time.
I might offer an alternative just as a challenge, okay, explanation, and say the same thing happened here as happened in Peter Schmidt's Compare-Absorb, where they had the granularity of data to see that they had, despite the fact it's a randomized trial, increased duration of DAPT in the BBS treated compared to the Xience treated, and the reduction is in total MI, not in target vessel MI. And we don't have so that could be an explanation, even separate and distinct from this, quote, passivation concept. Dr. Saidi, how can you respond to that? Do you have data that you could see the duration of DAPT one way or the other?
Unfortunately not. I mean, we do know that the initial regimen of medication the patients are on, and what kind of medication they're on if they come back with a new episode of MI or target lesion revascularization and so on. However, we don't have a way of knowing if the physicians chose to prolong DAPT in a certain group of patients because of their clinical experience on us. So unfortunately, that bit is going to be unanswered.
Yeah. The other thing is all these data seem to, and Gregg, Patrick, despite our best intention, all these data show hazard to 3 years and then show similarity in outcomes for the most part beyond 3 years, out to 5 years in the big meta-analysis, to 7 years and Compare-Absorb in these data for the most part. So my question has been, and you've heard me say this, Gregg, gone but not forgotten. Why is it that the BVS beyond 3 years doesn't appear to significantly outperform the metallic device, which we know is going to be there? Is it variability or incomplete resorption? Is it lack of sustained radial support? Is it what we've talked about at times, a acidic microenvironment, accelerated neoatherosclerosis? Patrick or Gregg, you guys take that on, because I was disappointed beyond 3 years.
Well, again, we had limited power, in the Absorb meta-analysis to really see, because there's only a 2-year period. And we really wanted, from 3 to 5 years, and we really wanted to get 10-year follow-up, but the sponsor wouldn't support 10-year follow-up. So I will say that from 3 to 5 years, we saw identical rates of TLR Okay, and here these were very carefully adjudicated, which is different, I think, from other experiences. And of course, this is all randomized data, so there's no residual confounding. So, but it was 2.4 versus 2.4%. We saw identical rates of target vessel myocardial infarction from 3 to 5 years in both the metallic DES and the absorbable groups, 1.7%. So we didn't see a hint of even getting better or getting worse. We did see a hint of a little bit less stent thrombosis. We saw a hint, interestingly, of less cardiac death. And so for that reason, we saw a hint of less target lesion failure. But to your question, is it just a matter of follow-up duration? I mean, I think Patrick should comment on this because I think he and his group have done the most elegant work on the potential theoretical benefits of restoration of cyclical pulsatility, the elimination of the permanent cage from which additional late neoatherosclerosis can only develop within. But you do have to remember it's there for the better part of 2 or 3 years. And the old scaffold is causing trouble within 2 or 3 years. Some of that, it still can form neoatherosclerosis. We've seen certainly cases of that. You can have late scaffold dismantling, which can occur within the first 3 years. And that may lead to events within the first 3 years, but it also may lead to fibrinoid and other structures inside the lumen that may persist even after you have complete bioresorption of the PLLA material. So, the last point I want to make before hearing from Patrick is that I think we want to emphasize that even if the outcomes are nearly identical from 3 years and beyond, if we could have a risk period within the first 3 years where there is no increased risk, identical outcomes with metallic DES and bioresorbable technology, either in all lesions or in a large proportion of lesions, that I think this would become a favorite technology because there are a lot of subtle aspects of it that you just can never really test. Okay, so the concept of unjailing side branches to allow later access, the concept of unlayering diffuse disease, okay, to allow further later treatment or bypass grafts. In case of in-stent restenosis, unlayering recurrent layers of stents. I mean, there's, as well as the cultural and religious and personal preferences to not have permanent things inside your body. So I think it would become very popular as long as, better scaffold technology, better implant technique, use of intravascular imaging, and appropriate lesion selection, allows us to get equivalent early results with newer scaffolds.
Yeah. My favorite philosopher always say, life can be understood backwards, but has to be lived forward. So it's very difficult to see where we are over 5 or 10 years. I think the landscape is changing dramatically. That's the first point. I think the pharma is changing in a dramatic way. We still don't treat very well our PCI patient. That's the first point. I mean, still on our trial in 24, 25, 15% of the patient have the correct LDL, and so that's point number one. The other thing, they are, I think, serious competitors. I think there will be a third of a fourth generation with thin struts. It is coming. It is on the horizon. We know that these big struts of 150, 160 were not very well tolerated initially. If you have something much thinner as a strut, it might be more directly encapsulated and covered so that you don't have these critical disruption of the struts at the time of the dismantling. So new generation using specifically the polylactide, but clearly the magnesium is making progress, and Ron Waxman and others have shown that they are less thrombotic in some way. They are even favorable in terms of thrombose. And then there are all these newcomers coming. I mean, think about drug-coating balloon. I think the United States will investigate that intensively in the upcoming years. And it's always another scenario for I don't leave anything behind. And then finally, we have to keep an eye on the bioadapter. Yeah, because the bioadapter with the publication of Cyto 2 years follow-up seems to challenge the official drug-eluting stand, in the sense that the rate of event seems to be reduced in the last 6 months, the second years. So I'm keeping an eye on that. It's maybe the hybrid that we want to have with some return of pulsatility and flexibility. So I'll keep an eye on that, and I'm sure the data will keep. So it's landscape is changing. Yeah, clearly.
Dr. Saidi, I want to reach out to you because you've been kept quiet here. What are your reflections on this? Were you disappointed beyond? Is it really worth the hazard for 3 years to have that reduction in myocardial infarction that may actually be explained by antiplatelet therapy? It may be explained by passivation of the target site, the scaffolded area. What are your feelings looking at the absorbed BVS relative to new generation DES?
I mean, the more I read about this and the more I work with this, I understand that the pathophysiology is much more complex than one would expect. So there are a number of things that we probably don't know, which may change the way we think about patient selection or what kind of device to use in different scenarios. So I would think that patient selection is one of the key things here to make sure that people, for example, live long enough to experience the benefits of bioresorbable products, because the current generation, at least, has got you've got a bump you need to get over before you get to the benefits of the devices.
That's excellent. Any final comments in closing?
I think the key here is that we need to get the next evolution of technology, which has certainly improved, back into the coronary arteries in, well thought out, large scale investigation. I mean, I certainly agree with Patrick about the novelty and intriguing results from the bioadapter, and we need to see the 2-year results from Infinity Sweetheart. I'm very anxiously awaiting those. But of course, Abbott, the original manufacturer of the first generation absorb BVS, now has a second generation technology, which has been used very successfully below the knee. And so I think to bring that back into the coronary arteries, I and others have been advocating for, and obviously it's a major commercial decision. But that technology looks better. We now have a class 1 indication for use of intravascular imaging in basically all PCI procedures, and let alone if we're going to bring back BVS. And so I think the use of intravascular imaging to guide implantation of Esprit or other, thinner strut technologies with better expansion properties to ensure apposition against the vessel wall, which I believe is much more important with bioresorbable technology than metallic DES, to prevent late scaffold dismantling and its consequences. I do believe that we can get very similar, likely would now achieve similar short-term results, 2 to 3 years, with bioresorbable technology compared to metallic DES. And then we're thinking of a whole new ballgame. But lesion selection is very important. There was a lot of hubris with the first BVS to just totally replace metallic DES, treat small vessels, treat 2-stent bifurcations, treat long diffuse calcified disease. And that's not the best place for this technology, at least not with current polymer technology. This device works very well in larger vessels, softer lesions, without a lot of calcification, where you don't have to overlap stent struts and bifurcations, etc. And that may be 60% of what we do. And I think think in those types of lesions guided by intravascular imaging with a better scaffold technology, I think there's a real future for this technology.
Well, that is a fantastic way to end. I want to congratulate Dr. Saman Saidi for a great paper that'll be published in SCAI, and also thank you for your excellent presentation. Gregg Stone, Serruys, couldn't get any better than this. So I am thrilled with the platform, and I want to acknowledge and thank SCAI for giving us this opportunity to bring thought leaders together and to have this type of a meaningful discussion on an important new publication. Thank you.